continuation of the previous video. Now this is task 2. Now we see the step 1. Now again we have to do for ramp and parabolic. So the important thing is for this is the step 1. You see step with the input 5. Again gain is different. This is the error we are displaying here. Now if we move to next one, what I did, I just copy it again, only change the ramp. So look at the error with the ramp. Again the last one is important, where parabolic, because parabolic input is not available in the library. So what I did, I used the integration, so it make us the parabola here. So again calculate the error. So what you learn from this, that as you increase the value of k, your steady state error is decreasing. Now if I move to second task, that is you just have to fill this table using this implementation. Now second task is for question number 7. What did question number 7 is that you increase the type of the system. So you have to now change the k values 5, 15 and 150. So what how I do that, I just have my task number 3 here. So what I did, I just copy the previous task, and what I did, I just change here again 5, 15 and 150. Again this is a step input, just I introduce integral here so that type is increasing. So again I run it. So again you see that as increase the gain, our error is decreasing. Now this is for step input. Again for ramp input, only difference is this integral. And the last one is the parabolic input. Again integration of ramp makes the parabola, and again integral at the end. So this is my task number 3. Now I have to move to next task, that is task number 4, and I have to fill this table, which I can do it very easily with Simulink. Now task number 4. Now we have to look for positive feedback. We have two cases. This is G5 divided by S plus 12 and H of S1, again the second one. So what I did, I just again go to MATLAB, open the Simulink file. Now this is task number 4. Look here, in task number 4 I put transfer function with positive feedback. Again input is 1 and the reciprocal of the input with same transfer function. Second part, this transfer function with the input and reciprocal of the input. So what happened when I multiply the input with negative sign, my error is also negative. So this is our task number 4. So if I move back again to my lab, so task number 4, I have to give the explanation why I get this. Now again after that we have a disturbances. Now if you know that this is the unwanted input to the system, you have to make this open loop Simulink block diagram and calculate the error. So this is for closed loop. So task 5 is for open loop, that I didn't do it. So you can do it, just put the value. I do it for closed loop. For task 6, okay. So how I do that, I just make, for example, this is task number 5, okay. So I have to remove this what you say, this bit, I have to remove it so that it's not feedback. So I have to then this is our task number, what you say, 5 for open loop. The only difference is that I have to take this at the end and compare with the input. So and this is a bit tricky here. So what I have to do, then it becomes an open loop, okay. So this is for closed loop. So you can do it. The main idea is that I take a summation here to introduce the disturbance here. in both cases. Okay, now if I move back